Let's explore multidimensional arrays in the C programming language. Multidimensional arrays allow you to organize data in more than one dimension. We will be looking at working with two-dimensional and three-dimensional arrays. These are useful for representing things like tables, matrices, and grids of data. Here's how to declare and initialize two-dimensional arrays. The syntax for declaring a two-dimensional array involves specifying the data type followed by the array name and the size of each dimension within square brackets. For example, int matrix 3 by 4 declares a two-dimensional array named matrix with 3 rows and 4 columns. To declare and initialize a two-dimensional array at the same time, you can use nested curly braces to specify the values for each element. In this example, each inner set of curly braces represents one row of the matrix. Key points to remember are that the first index represents the rows, and the second index represents the columns. The total number of elements in the array is equal to the product of the number of rows and columns. Also, the elements are stored in row major order in memory, meaning that all elements of the first row are stored first, followed by the elements of the second row, and so on. Initialization uses nested curly braces where each inner set represents one row. Let's see how to access individual elements within a two-dimensional array. To access an element, you specify its row and column indices within square brackets. For example, matrix 1, 2 would access the element at the second row in the third column, which has a value of 7. Keep in mind that array indices start at 0 in the C language. You can also modify an element by assigning a new value to it, using the assignment operator. For example, matrix 0, 3 equals 42 would change the value of the element at the first row in the fourth column to 42. As shown in the memory representation, the array elements are stored in contiguous memory locations in row major order. This means that the elements of the first row are stored first, followed by the elements of the second row, and so on. The arrows indicate the sequential order in which the elements are stored in memory. To process all the elements in a two-dimensional array, you typically use nested loops. The outer loop iterates through the rows, while the inner loop iterates through the columns. This allows you to visit each element in the array and perform some operation on it. In this example, the code prints out all the elements of the matrix along with a new line after each row. The output shows the elements of the matrix printed in row major order. Using row major traversal is the most efficient way to access the elements of a two-dimensional array because it matches how the elements are stored in memory. Let's extend our knowledge to three-dimensional arrays. In C, you can declare and initialize three-dimensional arrays, which are essentially arrays of two-dimensional arrays. To declare a three-dimensional array, you specify the data type followed by the array name and the size of each dimension within square brackets. For example, int cube 2 by 3 by 4 declares a three-dimensional array named cube with 2 layers, 3 rows, and 4 columns. Initialization is similar to two-dimensional arrays, but with an additional level of nesting to represent the layers. Each inner set of curly braces represents one layer of the cube. In this visualization, we have 2 layers. Layer 0 and Layer 1, each containing 3 rows and 2 columns. To access individual elements, you specify 3 indices: the layer index, the row index, and the column index. For example, cube 0, 1, 0 would access the element at the first layer, second row, and first column, which has a value of 3. Similarly, cube 1, 2, 1 would access the element at the second layer, third row, and second column, which has a value of 12. Let's explore practical applications, best practices, and common pitfalls when working with multidimensional arrays. When passing two-dimensional arrays to functions, you need to specify the size of the second dimension in the function signature. This allows the compiler to correctly calculate the memory offsets for accessing the array elements. For example, in the process matrix function, the ARR parameter is declared as int array of an unspecified number of rows and 4 columns. The rows parameter is used to specify the number of rows in the array. Dynamic allocation is an advanced technique that allows you to allocate memory for multidimensional arrays at runtime. This is useful when you don't know the size of the array at compile time. You can allocate memory for each row of the matrix individually using malloc function. Some real-world applications of multi-dimensional arrays include game development where 2D arrays are used for game boards, data analysis where matrices are used for statistical calculations, image processing where pixel manipulation uses 2D arrays for filters and transformations, and machine learning where 3D arrays are used for feature maps in convolutional neural networks. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.